Ministry of here, Ministry of
Hello. Okay. Good evening, everyone. Welcome to the live session 4 of this NPTEL course, Non-Conventional Energy Resources. So, I think I am audible to all you guys. Can anyone confirm am I audible or not? Okay. Okay. Good. Let me share my screen. Okay. So, let's start this session. Okay. Once again, I welcome you all to the NPTEL course Non-Conventional Energy Resources. This is a live session 4 being conducted by me. I am a PR scholar at IIT Bombay. This course, Non-Conventional Energy Resources, is taught by Professor Pratap Haridas. He is professor in Department of Metallurgical and Material Sciences, IIT Madras. So, how I have planned this session actually? So, we will take up some questions from non-graded assignments of this year. After solving those questions, we will have a fair idea of how to solve these questions, how to approach, how to grab the concepts of different things that are discussed in weekly lectures. Also, we will move towards the graded assignments of previous run of this course. So the graded assignment questions are from previous run, not from this run. So this run assignments has to be solved by you guys. Okay. So we'll have a good discussion here about the assignment questions. Also, if there are any issues, any queries, any discussion you want to have on assignment questions or any other queries, you can ask. So this session has been planned as a interactive session between you and me, guys. So this is how this session has been planned, and I think we should continue with this. Okay. So moving to the first slide. The first slide has a question, a black body observes radiation incident on it. Okay, it's like someone wants to join. Okay. The first question says a black body observes radiation incident on it. So we want to see this question. There is a main concept here, black body. So you need to know this concept. Can be a, what body can be termed as a black body? What is a black body first? And there's radiation incident on it. So another thing is that which type of radiation? Okay, black body, what is black body, and the second thing is which type of radiation incident on it. Okay, that is getting absorbed by black body. So if you see a black body, any body, okay, that it's this is a body. So any structure that has the inherent property of absorbing any radiation emitted on it from any incident angle and any wavelength. Okay. So when we talk black body, specifically means any radiation incident on a body with any direction, whether it is this direction, direction. Okay. At any angle and any wavelength, whether it is UV, IR, visible spectrum, anything incident on it is getting absorbed. So this body can be termed as black body. So let me be clear here. for the concept or for the understanding. Anybody on this earth or anything is can be very near to black body but cannot be a whole totally a black body. Okay. So this is the main concept here. There is a body. It's an imaginary body that can absorb any radiation at any incident, any angle incident on it. Okay. So a black body, what was the concept here? A black body will absorb any radiation incident on it. So yeah, black body absorbs radiation incident on it. It's a true statement. Okay, so the correct answer is true. We have discussed what can be termed as black body. Okay, so second thing we discussed that it can absorb any radiation, not only visual spectrum but IR, UV, anything incident on it, it can. So we are talking about any radiation. So here also I have given a definition of black body. If you want, you can note it down also. What can be termed as a black body? So black body basically absorbs all radiation, a body that absorbs all radiation at all wavelengths. Okay. Nobody wants to join? Okay. Okay. So I'm sure that you must have got a fair idea about what can be termed as a black hole. Now a trick question for you guys. How much is the emissivity of black body and a white body? Okay. So a black body we have discovered what can be termed as black body. As for white body, anything which is just opposite to black body can be termed as white body. Okay. More simple layman terms I'm saying. This is strict definition for white body also like black body, but for layman terms for your understanding purposes, you can just think that if anything is black body, the property is opposite to it, optical property is opposite to it is white body. Okay. So how much is the emissivity of black body and white body? What is emissivity? First, we need to think on this. What is emissivity? What can be termed as emissivity? So, emissivity is basically how much is the spectrum that is getting that leaves the surface of body. So, if this is a body or any structure, any rigid structure or any unrigid structure, if leaving from this body, since collectively this is called emissivity of this body or of this surface. So how much is the emissivity of the black body since it absorbs all radiation? So by default the emissivity of a black body has been defined as 1 because it all the radiation is absorbed. And what is the emissivity of black body? So just opposite to the what we have discussed in black body. So if black body has emissivity of 1, what will be the emissivity of white body? Simple 0. Okay. So emissivity of white body is 0, emissivity of black body is 1. Okay. So I'm sure that you must have got a good idea about what can be termed as a black body, what is a white body. So if anything you see on like in your house or on your rooftop, anything when you visit on the market or anything, so you can identify that something is absorbing a lot of radiation. It's getting hot. So what happens if some structure absorbs a lot of radiation? So what happens? The temperature is increased. Why? Because the internal energy of the particle is increased. If it's solid, then certainly the vibration will occur at molecular levels that will capture energy from incident radiation. You can simply say that internal energy can be increased here. So internal energy is basically a function of temperature. If internal energy increases, then temperature of this body will also increase. Okay, so how you can identify that if it is absorbing a lot of radiation, it's very near to a black body. Okay, so if there are any questions regarding this black body thing and radiation or something you want to know, You can also type in your questions in the chat box. I can read them, or you can always ask in between. Okay. Also, you are suggested to ask questions in the discussion forum also of the NPTEL, so that all other students who are not able to join this live session can benefit from your question. Let me see if somebody wants to join. Okay, nobody wants to join, and there are no questions here. Let's move to question 2. So question 2 says the solar concentrators can help raise the temperature of water above 100 degrees Celsius. So first thing is that question is asking about solar concentrators. Second thing is that whether it can raise the temperature of water above 100 degrees Celsius or not. So this is a purely conceptual question based on different experiment that has been performed on solar concentrators. See if somebody wants to join. Okay. So saying here you need to know what are the solar concentrators. Plus, the solar concentrators equal to raise the temperature of water over 100 degrees Celsius. So yeah, solar concentrators are basically devices. So be careful when I'm talking about solar concentrators. It is a device that concentrates the rays of sun coming to it. This is the rays of sun coming to it. Concentrates these rays to a specific focus. I think any is coming to it, it will certainly focus it to a specific focal point. What happens with the concentration rate, the temperature of this focal point or energy placed at this focal point will increase certainly. Okay, so is the temperature getting increased with the solar concentrator? So the first question which arises is how much can the raise in the temperature? Whether it is 50, 20 degrees Celsius, 100 degrees Celsius, 1000 degrees Celsius, what? So these are basically based on different experiments which have been found by various research groups, scientists all over the world. They have actually found that the solar computers or the designs have been evolved in such a way that the solar concentrators are much more efficient now. They can easily raise the temperature up to 100 degrees Celsius. So that's a quite huge amount. This temperature, I will say, that's quite a high level of temperature that can be raised with solar concentrators. This is a two state. Treatment is quite two. So here also we discussed what are solar concentrators. So I am sure that you got an idea of what devices can be solar concentrators. Other thing is that is it necessary that solar concentrators has to be curved only? Like this case, there is a parabolic solar concentrator. But can it be linear, like this straight line mirror or something? What happens to mirror if the rays of light first mirror? What happens? Rays of light gets reflected back 180 degree. Okay. If this is the case, the rays of light gets reflected back, what happens if we tilt this mirror? So if rays are coming from this direction, it will certainly be diverted to this direction. 'Cause. 'Direction. 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 'Cause. ' So that's how these linear Fresnel reflectors or linear collectors are used. They are actually tilted to some angle which concentrates of the rays of light to a particular point. So there can be a arrays or quite a huge amount of these linear Fresnel reflectors which are placed on the ground. And these reflectors can actually focus the rays of light at a particular point that will raise the temperature. So I'm sure that now you have got an idea that parabolic, whether the solar concentrators can be parabolic or it can be linear also. So it does not matter whether it is parabolic or linear. Main focus of solar concentrator is concentrating the different rays coming from sun to a particular point. That is the basic concept of solar. Okay. So with that I put this of solar concentrator also so that you guys can get an idea of what is a solar concentrator. So I can make a lot of drawings, schematics on it, but until unless you have a good picture in your mind, uh, you cannot visualize solar concentrators. Okay, so I put two pictures here just for your sake of understanding. So if this is parabolic gas concentrator, so I'm sure that most of you guys have seen regular antenna discs, that huge cable TV discs. So that huge cable TV disc can itself act as a solar concentrator. So earlier what it was doing, it was collecting rays, TV rays of K band to the and focusing it on a point, and that antenna or collector actually converts it to electrical signal, and this electrical signal goes to your TV and you see the channel. Similar thing is seen here. The rays coming from sun is actually focused to a receiver. This focal point is called receiver here, and the temperature of this receiver actually suits up for the focusing of rays. So not only this concentration can go up to 1000, so the ratio of focusing can go up to 1000. So that's a quite huge amount, and temperature can range at degrees Celsius also. Okay. So this is quite a concept of focusing or concentrating for rays. Uh, it basically utilizes a parabolic gas and focusing the rays coming to a particular receiver. What happened in linear Fresnel vector? So I think I discussed here there are the arrays of mirrors that focus the rays to a point. So similarly, you can see here, and there are arrays of mirrors. So these gray things which you are seeing here are basically mirrors. So there are arrays of mirrors that focus the rays of light coming from sun to a particular receiver. So what we put receiver, we put a pipe over and flows through it. So if water flows through a pipe of copper and rays are focused on it, what happens? The temperature of the water will rise. So it can rise very high, up to 200 to 50 degrees Celsius or even more than that. It can be converted to steam also. So this is how a linear Fresnel reflector works by focusing the different rays from different angle to a particular okay, and linear parabolic is reflector. Basically, a parabolic base which passes the ray to a particular receiver. So the basic difference between these two utilities and linear Fresnel reflectors. So we'll discuss these things one by one, better slides, and also I will suggest to go through the weekly lectures uploaded by Professor himself, and he has actually explained the different types of working principle behind these devices. Okay, and we'll get to know more about these devices in main lectures. So if there are any questions, feel free to ask. If there are any questions regarding this question 3, see if somebody wants to join. Okay, no one wants to join. Okay, since there are no questions from your side, I think we can move to slide 3. Question 3. So, question 3 basically is about, see, the recording is going on. Okay, so question 3 basically asks about a parabolic disconcertator typically it tracking because it is curved in all directions. You see, this thing it is asking is parabolic disconcertator. Okay, so this is parabolic disconcertator, and it is saying that it doesn't tracking. So why do we need tracking? First thing, the first question should come in your mind. So the first question should come to your mind: why do we need, and because it is curved in all directions, so you can say that concentrators are basically concentrators which are inherently curved. So any rays which are so this imagine this is a ray, so it will get concentrated to this. Okay, this is the ray. It will focus on this. Similarly, if any rays are it will focus on. Okay, see rays are focused to the receiver itself. A picture here also for your quite good understanding about parabolic disc concentrator. So this is a parabolic disc concentrator. These rays can be focused here, parabolic disc concentrator. And why do we need the tracking? Because what happens? So this is Earth, okay, and uh, you see, okay. So Earth is basically something like this. So you are here. Sun in the morning at, let's say, 7 a.m. Sun is here to your eyes. Okay, sun. This is sun. What happens? This sun goes. Just at 12 o'clock, it's overhead here. Sorry, it's PM. By the evening, what happens? It's come down. Sits in the west by, let's say, 6:30. You see that the sun is going up in the sky, then coming down to the horizon. So this angle, the rays which are striking here, it is this. What for this? The angle is theta. So this angle getting changed. This angle is changed. Not only this, but the its position on horizontal direction also gets changed. So if suppose instead of a human you have a parabolic disc concentrator here that is facing the sun. So in the morning the rays are falling perpendicularly to it, but in the noon the rays are just above it. So most of the rays won't strike it. By evening the rays are on its backside. So this, let me read it. So you could have, okay. So if this is like this, but if this parabolic disk concentrator changes with the movement of sun like this and in the evening like this, so it is able to collect all the rays perpendicular to it. And most of the rays which strike perpendicularly will generate a lot of will contribute to the temperature. Okay, so this is basically an arrangement of different mechanism, motors, links, which actually helps in contributing the movement of this solar parabolic concentrator in all the directions, was so that the rays from sun falls perpendicularly to it. So this concept is called tracking. It's very important to have a tracking so that uh, it's very important to have a tracking so that you have a good idea, fair idea about how to collect all the rays perpendicularly to it. So yeah, a parabolic disk concentrator typically needs tracking. Okay, it doesn't need it's need tracking because it is curved in all directions. So it's a first statement. Okay, and this is the parabolic disk turf concentrator. So if you see, this is the tracking motor, azimuth drive. This is not, this is Stirling motor and this is another thing. Okay, so these rail azimuth are basically tracking devices, elevation rail, link, truss, elevation bearing, concentrator. So it's not the solar devices are not so easy to build. It's a very complex design which are uh, put in place to actually focus and rise in temperature. Okay, so that's how these devices actually work. And if you want, you can take a screenshot of this also. Otherwise, I will upload the slides so that you can get the various parts which are present in the solar concentrator, parabolic disk concentrator. Okay, so this is basically concentrator cell main part. This is receiver main part, and these are various links for supporting this parabolic disk concentrator. Okay, so if there are any questions, let me see if somebody has asked any questions. Okay, no questions. Okay, so I think we should move to next question then. The fourth question says that a glass plate is used on the top of flat plate collector in order to prevent IR radiation from coming in. So is it true or not? Okay, so first thing it's asking glass plate. So this secondary thing. First thing is that it's asking about flat plate collector. So you need to know the concept. What is a flat plate collector? So this diagram I have taken from Pennsylvania State University. So I think this diagram very beautifully explains a flat plate collector. So what happens in case of flat plate collector? There is a collector. Uh, it has some tubes here. So these are basically copper tubes. Uh, Through these tubes, the fluid flows in it, and above these tubes there is a reflective coating, selective coating, not reflective coating, selective coating. Okay, so it's basically try to we try to make it a black body so that anything incident on it get absorbed by this black coating plate, and the heat is transferred to these tubes so that the water or any fluid inside it can be heated. Okay. So what happens? Solar radiation are actually very powerful, so it has a very short wavelength. A short. and what happens when it enters and get reflected back, it converts to long wavelength. Okay, so these glass panels are transparent, so it actually allows for the passage of short wavelength sun rays and gets converted to long ranges, which are basically trapped by these glass panels, long wavelength. And another thing is that it doesn't prevent infrared radiation. Okay, so it doesn't prevent infrared radiation. Because infrared, what happens with infrared? It produces heat. So heat is the main property here. So why do we need to stop infrared by putting a glass panel? So certainly this is a wrong statement about the glass panel. So this is basically a false statement. So the correct answer is false. And the main thing is that these glass panels are very much actually effective in trapping the heat. So these somewhat the behavior of these glass panels are actually, or the whole thing is that you have heard of these greenhouses in cold country where the heat enters, the sun rays enters and the rays got trapped and it raises the temperature of the anything which is inside those greenhouse gases. So the term greenhouse gas effect is also present because of those greenhouse gases. So these glass panels actually behave in the similar manner of those greenhouse gases. So no change, nothing. So basically, similar phenomena. The heat is actually heat generated is basically utilized to heat the fluid which is inside those copper tubes. Okay, I think someone wants to join. So let me see if somebody wants to join. So this is how a flat plate collector actually works in order to prevent the uh, glass panel is basically. So this is basically a wrong statement, a false statement. Okay. So any questions are basically based on the concept. So if you know the concept, what is a flat plate collector, how what are the function of those glass covers above those flat plate collectors, and how are they utilized to actually heat or something. So if you know these properties, this function, the overall working principle, you will very easily answer these type of questions. These are not so difficult questions. Okay, so try to visualize it. These questions. Try to visualize a flat plate collector. If you could visualize a flat plate collector, you could easily understand the usage or function of glass panels, the tubes, the different black covers. So maybe the question can be these black absorber plates are coated in white. So how can it be coated in white? If it is coated in white, it will reflect all the sun rays. This cannot be coated in white. This has to be a black body so that it absorbs all the radiation falling on it, and the radiations are actually absorbed by the fluid which is flowing through these copper tubes or something. So basically, copper tubes are utilized because copper has a very high thermal conductivity of 385 watt per meter square Kelvin, very high thermal conductivity. So that's why copper is utilized. Or if it's coated, then my steel or stainless steel tubes can also be utilized, but copper are very much preferable in these cases. Okay, let me see, someone wants to join. Okay, so I'm sure you must have got a fair idea of what is a flat plate collector, how it is used, and what is the role or functions of glass panels above it. Now, the question number 5 says that humans and animals give out infrared radiation. So, yeah, it's correct. Humans and animals give out infrared radiation. So, anything, anybody, and I am talking this term body, any body Why body? Because any matter or something which has some temperature will emit some radiation, and it will emit radiation. If it's the has a temperature, it will certainly emit some very minute. If the temperature is very low, it will the radiation will be very minute in infrared terms, but there will be radiation always. If there is temperature, there is infrared radiation. So the main property of this infrared radiation is to provide heat. It's basically a carrier of heat. So yeah, humans have a normal average body temperature of I think 21.5 degrees Celsius, and animals have some higher body temperature, or maybe colder also, because cold blooded animals are also there, warm blooded animals are also there. So based on their bodily characteristics, they emit some infrared radiation. So it's an inherent property itself. So yeah, this question, this thing is actually very much true. So humans and animals give out infrared radiation. Now the next thing which is discussed here is, which I am trying to put here, is that what can be termed as infrared radiation. So if you see 7,000 to 1,000 or something, this 400 to 700 nm, this is visible light. So what do we mean by visible light? So any light which can be seen with naked eyes. So these actually any light or the light which is being seen with naked eyes is visible light. So it's not a single spectrum or white or something which you see or feel. It's basically a combination of different types of spectrum ranging from purple to red. So if the wavelength is beyond red, okay, beyond red, mark my words itself, okay, 700 nm and beyond. So it's called infrared, like in 1000 or 0.01. If it's below this violet color, okay, so this is ultraviolet. Okay. Ultraviolet X-ray gamma, these are very harmful, very very harmful. And infrared radio, radio, these are actually very much pretty useful waves, but these are very harmful, radioactive also. X-ray gamma rays are very radioactive, so you need to be very careful about sun rays. Sun rays are also sources of energy, but they are also sources of different types of harmful rays also. So, and with increase in wavelength, the energy actually decreases by, so you know the term is C upon lambda. So HA Planck's constant. This is light, speed of light, which is constant, 3 to 10 power 8 meter per second. So what can be measured? Lambda. Its energy is directly proportional to, inversely proportional to lambda. As the lambda is increased, energy goes down. Okay. So with this, the non-graded questions of the assignment of week 3 is actually finished. Week 4 is finished. So I think you must have got a very pretty good understanding about how to approach the ungraded question, and most of you have got it correctly also, but you need to know the underlying concept about asking these questions. These questions are actually test your fundamentals. These are very important for to knowing that or recalling your fundamentals. Most of you have learned it very earlier, so this will actually help in recalling the fundamentals also. Okay, so yeah, and so this is, I think there are no questions. If there are no questions, so let's take a break of few minutes because the non-graded questions are finished. So we'll let's have a break of 5 minutes. Then we will again continue with the graded questions. These graded questions are from previous run of the course. Okay, so So let's start again. I think you haven't asked any question. So let's start. Join. Okay. So we were discussing these non-graded assignment questions. So I think you must have got a fair idea of the non-graded assignment questions. And so the non-graded assignment questions will move towards the graded assignment questions. Okay. So the first question is basically asking about wavelength of the most intense part of a spectrum associated with a black body with increase of temperature. So here it is talking about wavelength, spectrum, black body, temperature. Four things. Wavelength is one. So we'll discuss about wavelength later. A spectrum, consists of seven. It's basically a collection of all the wavelengths of different types like infrared, UV, visible, X-rays, gamma rays, everything. Okay. And black body we have discussed in the earlier slide also. Any body which actually absorbs all the radiation incident on it from all the angles. And basically, if it's talking about temperature, so if temperature increase, wavelength actually decreases. I will discuss also why. So don't worry. The correct answer is decrease. Okay, so first thing we'll discuss wavelength. Okay, so there are waveforms. If you think of any wave, X-rays, gamma rays, so there are waveforms which move like this. Okay, so any two adjacent highs or any two adjacent lows. Okay, so these are called. This is the length. So any two adjacent. So this cannot be between this and this. This has to be between this. So any two adjacent highs or any two adjacent lows, this length is actually constant for a waveform. This is called wavelength. Okay. So now you have understood what is a wavelength actually. So this is basically a wavelength. So okay. Another thing is that spectrum, basically X-ray, gamma ray, collection of different types of rays. Black body and temperature. So what happens with increase in temperature? So these wavelengths, if the temperature increases, the molecule vibrates at much faster rate. So this is a molecule. So at a particular temperature T1, 25 degrees Celsius, it's vibrating very slowly, 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 slowly. But as we increase it to 250, these molecules actually vibrate at much faster rate, much faster, much faster, much faster. So what happens within a second? The number of waveforms increases. These highs or lows. Okay, so they become the length become so small. Earlier it was within a second. It was like this, and the temperature was low. But as the temperature increased 10 times, this is like this. So what happens? The wavelength actually between these two crests actually decreases. So now you got to know why the wavelength of the most intense part of spectrum associated with a black body decreases with increase in temperature. So is there are any questions you can ask me regarding this concept? Okay, there are no questions. So, yeah, let's move to question 7. Then this was a pretty understandable question. If you have learned physics in class 12, or if you haven't learned physics also, there are various phenomena in the nature also which follow this pattern of wavelength. Okay, so you just have to understand, you just have to observe the nature, and you will get a lot to learn from out of it. Okay, so okay, so I have tried to put in some facts here, like about this black body, because we were talking about black body here. We talked earlier about black body also, so I tried to put in some facts. So basically, the first black body was basically designed by Khrushchev. So you must have heard about Khrushchev's law, and so he designed it in 1859. And there are some known properties also of black body radiation. So actually, a lot of studies has actually gone to it. And based on those studies, the experimental results, we can say that as the temperature of the body increases, the intensity of radiation from body also increases. So intensity is basically amount of radiation per unit area. Okay. So intensity as the temperature increases, more and more rays are emitted. So intensity of radiation increases. Higher the temperature, lower the wavelength of the most intense part of the spectrum. So we have actually discussed it in last slide also how the temperature was actually affecting the wavelength, the distance between those wavelengths, and wave highs and lows. So the lows are called crest, highs are called I don't know, maybe crest and pitches or something. Okay, so I don't remember the exact word. Crest and trough. Okay, the crest are highs, trough is I think lows. Okay, crest and trough. So I think you must have got a good understanding of this wavelength thing about black body. Uh, this is basically a concept which is very much utilized in black bodies, which is very much utilized in because we are talking about rays only. We are focusing rays to generate electricity. So if to generate electricity, then there must be a particular understanding about how the this black body thing is actually working. So based on the properties has been determined with different experiments, different observations also. So yeah, this is how has been obtained. So if there are no questions, I think we can move to the next slides. Okay, so let's move to the next slide. This is question 7. So I want you guys to actually focus on this question, read the question, what this question is saying. So this question is saying that the dash constant helps in understanding the lower wavelength region of the spectral irradiance versus temperature plot as a temperature T as well as S. Okay, so there this question is basically it's not a conceptual question, it's a basically memory based question. So there are various laws, various constant Boltzmann constant, Planck's constant, photoelectric effect, electrochemical effect. So you just need to know which effect is actually contributing here or being taught here. So if you know these answers, you will get to know the answer of this question very easily. So try to focus on this question. I want you guys to understand and try to uh, think about it. What can be the answer? Okay, so if we focus on this question, So it's basically Planck's constant. Okay, so what is the value of Planck's constant? It is denoted by H 6.626 into 10 to power 26 or 24 something. This is the Planck's constant. So Planck's constant helps in understanding the lower wavelength region of spectral radius was a temperature plot as temperature T as well as which effect photoelectric effect. So we'll talk about photoelectric effect in the next slide because it is a very important phenomena which has actually uh, determined or led to the development of solar photovoltaic cells which directly converts the electricity solar sunlight to electricity. That was a phenomenal discovery, I will say. Okay, so uh, this is the actually Planck's constant help in understanding the lower wavelength region of spectral irradiance versus temperature plot at temperature T as well as the photoelectric effect. So let's move to this photoelectric effect. So I particularly put this slide so you need to understand so that you can understand what is photoelectric effect. So photoelectric effect, what it does tell you about is that if there is a metal plate, so certainly these metal plates will have some electrons. Okay. So what happens if a sunlight with h mu? So what is the energy of photon? Photons are basically constituent units of light. So the sunlight with photon energy h mu falls on the surface of this metal, and this metal electron has a work function of phi. So if this h mu has energy greater than this phi, then this electron will become free, and after becoming free it will eject from the surface. If this electron is actually put in a channel, so and a bulb is put here, so current can flow in this direction. Okay, so sorry, electrons can flow in this direction, current will flow in this direction. Okay? Now what is the equation here? So half mev square, that is kinetic energy of electrons, you know the kinetic energy formula, equal to h mu, that is coming from light, minus this work function of metal. So this is the basically a formula. Half mev square equal to h mu minus phi. So what is this work function? This work function is actually a pretty interesting thing to know. It's basically a thermodynamic property which says that what is the energy that is required for the electron to leave the surface of metal. So if this energy is actually measured, if it's phi and h mu is coming, which has energy greater than this phi, so what happens? The phi actually is taken from h mu to release the electrons, and the extra energy is actually converted to kinetic energy of electrons. So this is how this equation has been determined. So another thing is that I will tell you an interesting story about this photoelectric effect. A very interesting story. So most of you have known that the photoelectric effect was basically discovered by Albert Einstein. So he discovered it, and he in 1905 or six. Yeah, and he got Nobel Prize for this discovery in 1921. So it was basically a quite wonderful phenomena which he discovered. But the main thing is that he didn't discover photoelectric effect. Okay, Albert Einstein didn't. Let me write Albert. I must say Dr. Albert Einstein. So because all the scientists must be respected. All we are grateful and indebted to their discoveries. Maybe my spelling of Einstein may be wrong, so please check. Okay, so Albert Einstein actually explained this phenomenon in 1921 and 1906, and he got Nobel Prize for this. But the photoelectric effect was actually discovered by Hertz. So you must have heard about this unit Hertz. It's a unit of frequency, but Hertz unit is actually named on name of a scientist. He was a German physicist, and he was working on some radio waves or something. So that is where he discovered this photoelectric effect. So he didn't understood this whole phenomena. Albert Einstein got this information. He explained the whole phenomena, photoelectric effect, and for that explanation, he got the Nobel Prize. So this is how these two great scientists were associated with photoelectric effect. Okay, it's a very good discovery. Let me see if anybody wants to ask a question. No one. Okay. So we'll move to next question now. So just read this question. I think this is question from last topic. This is from last slide. This. Read this question. Then we will have a discussion on this question. So are you getting the question? Let me see if recording is on. Okay. So yeah, are you getting the question? The question is basically saying a particle of light is known as dash. It can only possess energy h mu. Okay. So h mu is basically energy of photon. So yeah, I told you the answer itself. So light is basically consists of various constituent particles. It's called photon, and it can only possess energy up to h mu. Why? Because energy is basically h mu. Mu is c upon lambda. So light has a fixed speed. This is constant, and the wavelength of light is also constant. Okay, so it travels through different. It doesn't. It travels from sun to earth in any without any medium. So it doesn't, because it's a radius and doesn't need. So it has been calculated that it can only possess energy up to 2 h mu. So yeah. So the correct answer is photon and 2 h mu. And for your understanding, I can say that the sun emits radiation of 384 iota watts. So how much is iota watts? Can anyone answer? It's 384 into 10 to the power 24 watts. So sun is, you can think of sun as a big, very big light bulb. So it is emitting 384 into 10 to the power 24 watt of energy. So if you compare the energy of sun with your incandescent bulb, so earlier times there was that yellow bulb in most of our houses. So that was a very old-fashioned bulb with which consumes a lot of energy, emits a lot of energy. So if that energy conversion is taken as 100%, so that electric bulb actually it's a 100-watt bulb. Okay. So compare this energy. It's a 100-watt bulb, 384 into 10 to the power 24 watts. So you can understand the sun is 384 into 10 to the power 24 times producing more energy than this 100-watt. Okay. So you can compare this power emitted by sun with your incandescent bulb. So That's sun is actually a pretty huge light bulb if you think in that term. It's giving light to the whole solar system. Uh, Everything on Earth is basically utilizing solar energy. The plants utilize the solar energy. Chlorophyll. This is a pigment called chlorophyll in plant. So it basically utilizes the visible spectrum of chlorophyll, chloro, CHLORO. Okay, PHYL. So this is actually uh, utilizes the energy from sun and converts it into different starch plus oxygen. So this is how the oxygen is actually produced. Okay. So let's see questions. So yeah, we don't have any questions here. The thing is that key this has been a quite long session, in fact, 2 hours. So, I know you guys are actually too much exhaustive for you also, but I want you to interact with different questions. Different. I want you to actually put forth your points and interact with me by typing your queries in the chat box also, so that I can get your queries. Or if you want, you can unmute your mic also and ask questions. Because a fruitful discussion is very much important for this course. This whole um, live interaction session. So what's it name? Live interaction session. We planned according to that only. We will have a lot of interaction, okay, regarding the courses. So let's move to the next question. So read the question, then we will. It seems like somebody wants to join. Okay. So yeah, we were discussing this question 10. So what this question 10 is saying that the full solar energy spectrum is consistent with dash, and the visible region of this lies between dash and dash. So if you for answering this question, let's move to this. Have a look at this. So visible region, if you talk about visible spectrum, 400 to 100, 700 nm. So it lies between ultraviolet and infrared. Okay, this is what this question is asking. The full solar energy spectrum is consistent with the actually black body radiation. So yeah, the full solar energy spectrum is actually considered consistent with the black body radiation, and the visual region of this lies between ultraviolet and infrared. So the correct answer is not brown body. This is the correct answer: black body and infrared and ultraviolet. Okay. So the correct answer is the full solar energy spectrum is consistent with the black body radiation, and the visible region of the lies between infrared and ultraviolet. So I have tried to put some trick questions here also. It's not a trick question; it's just to enhance your thinking abilities. So What I want to ask here is that is black body totally black? So let's discuss this. So what happens? Why it's called black body? So we've seen that if a surface is painted in black color, it absorbs most of the radiation falling on it. So that is where this term black body comes. But this is not the correct explanation of black body. Okay, so a black body can be of any color. The only definition which is said, it absorbs all the radiation coming from any direction from any point of any visible any spectrum region. Okay, so this is the definition of black body. So it necessarily doesn't need to be black, but generally it is black. Okay, so the correct answer is black body radiation and infrared and ultraviolet, and this is black body totally black. So no, it doesn't need to be totally black. Okay, so say time to join. So I think you must have got a good fair idea about this different spectrum and these things. So now this is the fact about solar energy. I think this has been discussed in the slides also. So if we get time today, we will discuss it here. Otherwise, I have actually discussed it in the last week live session also. So you can check that video and also get a good understanding about different this solar energy facts. You can go through videos also to have a fair understanding. Okay. So we'll discuss it if we get time today. Otherwise, we'll skip. So now the last five questions are basically from solar collectors. So to get a good idea about how this solar collector actually works and what are the various principles and concepts regarding the solar collectors, these questions are basically based on that. Okay. So flat plate collector is used to harness solar energy, requires dash conducting sheet made of dash material. So basically, flat plate collectors harness solar energy require thermally conductive heat. It doesn't need electrically. Why electrically or not magnetically? Because it needs heat. So heat is basically term associated with thermal. So it needs thermally conductive sheet made up of metal. It must be made up of metal. Okay, so metal is also correct, but basically it's made up of copper. So copper is also a metal. So metal is also correct answer. So the correct answer is B and C, thermally and metal and copper. Okay. Someone needs to join. Okay. So yeah, you got to know about this. So both of these B and C are correct answers regarding this thermally metal. Okay. Another thing that key you need to know the flat plate collector how it works, so you will be easily able to answer this question. So recall what is flat plate collector. So yeah, I think in slide 2 or 3 I've explained this flat plate collector thing with a diagram. So if you don't remember or if you have joined late, I will explain it again. So this is basically a flat plate collector. So what it does, it has a thermal insulation above it. The copper pipes are placed above copper pipes. The thermal black body plate or which absorbs the radiation plate here. There is a glass top at the glass cover at the top, which actually traps the solar radiation and converts it to longer so it can be trapped. And this black absorber plate actually absorbs the heat from those radiation and transfers the heat to the fluid which is flowing in the copper pipes. Okay, so these fluid tubes are nothing but copper pipes. This is how a thermal insulation. So here the heat is transferred, and this copper. The question is asking about this copper pipe. So yeah, copper is also metal. So B option is also correct. Okay. So when you get a question, try to think about it. So it doesn't mean that one option is correct, the other cannot be correct. Yeah, both options can also be correct. Basically, based on your understanding also. So if B and C both are correct, then you have to tick mark both of them, thermally metal and thermally top. Now we move to the question 12. So please read this question. I give you 2 minutes to understand and read this question, so that we will discuss and have understand what this question is actually saying. Okay, so if you see this question, this basically talking about metal sheet in solar energy collector coated with black color. So we have discussed this in flat plate collector also, that key metal sheet in solar energy collector, we have a metal sheet and it's coated in black color. So this is basically to actually increase the what you say, uh, thermal trapping of sunlight. So black color actually what it does, it actually reduces the reflection of the sunlight, so that most of it is getting absorbed. So we have this reflection plus transmission plus absorption equal to 1. So it reduces the reflection, most of it is getting absorbed. That's why it is black body. It absorbs all the radiations. It reduces the reflection of sunlight. It increases the absorption of sunlight. This is also correct. 1 and 2 is correct. Protect from the environment. So black color is not to protect from the environment. Protecting from the environment, the glass cover on the top and many other things are there, but not the black cover. Okay, so this is wrong answer. Correct answer is both 1 and 2. Reduce the reflection of the sunlight and increase the absorption of sunlight. Okay. Now I think this has been has to be understood. We see this question, the glass plate on a solar energy collector setup. So we have these three options here. Keep the visible radiation stuck between metal glass, sheet and glass. Second is reduces convective losses. Third is reduces infrared radiative losses. So if you see a flat plate collector which has a glass topping on the cover, so most of it is basically to trap the sunlight, uh, to convert it to uh, um, to trap the short wavelength of sunlight and convert it to long wavelength, because the long wavelength are very easily trapped inside the flat plate collector, and that trapping actually contributes to the trapping of heat, and this heat is actually absorbed by the black cover, which is selective black coating, which is above the plate, and that plate transfers the heat to the copper tubes, and through these copper tubes the fluid, generally it is water because we use it for water purpose only, heating the water. So these tubes are actually aligned in such a way that most of the heat is actually transferred to this fluid which is flowing through the tubes. So it's the question is basically asking on this only: a glass plate on a solar energy collector setup is what are its uses. So basically it is used for keeping the visual radiation stuck between metal sheet and glass. Yeah, this is the if this is a metal sheet and this is glass. So yeah, I think the question one is also correct here, because this actually traps the visual radiation, but it doesn't stuck. Visual radiation you cannot stuck the radiation between metal sheet and glass. Some of the radiation will also always get lost, because there is some transmittivity also, some reflectivity component also, plus some absorptivity component also. So some of these will get transmitted and get lost to the atmosphere. So yeah, you can minimize the convective loss through air, because air is flowing through the surface of this flat plate collector that will carry most of the heat from the black metal sheet. So glass cover has put a barrier between air and this metal sheet that actually contributes to the minimizing of convective losses. Also, the red radiative losses are minimized. How? Why? So any option you need to think about how it can be done. So yeah, what happens these short wavelengths are actually trapped and they converted to long wavelength. So with the conversion of short wavelength to long wavelength, what happens? So h mu 1 is the energy of short wavelength greater than h mu 2, which is energy of long wavelength. Okay, so this has much lesser energy, so it can easily be trapped inside. So radiative losses are actually what is done. It can be minimized because the wavelength has actually increased. Okay, so if you see this question, both 1, 2 and 3 both are correct here. So the correct answer is both 2 and 3. So just for sake of understanding about these different different celestial bodies, I put a scale here, like what's the Earth radius. So Earth radius is basically 6371 kilometer. If you think of Sun radius, it's 7 lakh kilometer. And compare the scale of Earth radius with Sun radius, it's 1,000 times more than Earth radius. Okay, and the Earth orbit around the Sun, the planet's orbit around the Sun is a particular pathway. So Earth orbit around the Sun is of 1.5 into 10 to the power 8 kilometer. So these are very huge quantity or huge number, which basically tells us about the scale of operation of these planets and different stars inside the solar system and inside the universe. So that's how when we talk of electromagnetic radiation, when we talk of this transfer of energy, so these things become very much important. Okay. There are any questions? Please type it in the chat box. I can see your questions here. Okay, no questions. Okay, so to the question here. Three of the questions are left. So the three questions and this session. So, talking about is that key statement is given and the reason is given. You need to read the statement and then think about the reasons and put mark or select the correct answer among the different options given. So, statement is the ability to pick up heat is limited by the area of flat plate collector exposed to the sun can be increased by replacing the tube by fins or mesh. So yeah, statement is correct because whatever is the area of flat plate collected can collect that much amount of radiation. So imagine flat plate collector having an area of this much and flat plate collector of having area only this much. So it will certainly collect much lesser amount of radiation than this bigger area collector. So if we have to increase this areas, what can be done? So yeah, it can be increased by replacing the tubes by fins or mesh, or you can add fins to the tubes itself. So what can be the possible region? So one thing is that when you add fins or mesh or anything of such structure or geometry, it actually increases the surface area. So you have seen a honeycomb. So what does honeycomb actually do? So honeycomb has a particular feature that actually makes the increase the surface area of the surface. So that actually makes exposes a much larger area to the atmosphere for heat transfer or anything. Yeah, fins and mesh have more surface area than tube. Fins increases more air resistance. Oh no, because we have a blast over at the top now. So the tubes are situated inside. Yeah. So we have glass cover at top, which actually reduces the air losses or reduces the contact with air. So yeah, more air resistance is not main problem here. So mainly the reason one is actually follows. Since MS have more surface area than tubes. Correct answer is only reason one. Okay. So I think you guys have got a good sense of understanding about this question. This question basically talks about different concepts which is utilized in a flat plate character. So if you cannot think about or visualize a flat plate character, it's very difficult to actually answer these type of questions, which are very much conceptual questions. Okay. So let's move to the next question. Next question says that parabolic disk reflectors are in a shape of dash mirror which uses the idea of concentrating solar energy at dash focal point. These are made up of highly polished stainless steel or aluminum surface. Yeah, it can be of any other surface also. Stainless steel, aluminum are quite good because it has a good resistance to corrosion. It has not that much cost. Also durable. Durability is also there are various properties which are actually malleability, durability, corrosivity, which actually shows that the stainless steel and surfaces are one of the best for utilizing it in parabolic disc reflectors. So, is asking that it's in the shape of dash mirror. You know, a convex mirror. This is a convex. This is a concave mirror. What happens in convex mirror? Any ray which is coming is actually focused to a particular point. In concave mirror, what happens? Any ray which is coming is it is not focused. It is actually diverged to a particular point from a particular. Somebody wants to join. Let me see who wants to join. So this is the actual difference between convex and concave surfaces. So when you talk about concentrating, so these parodic disk concentrators or solar concentrators. So when you talk about this concentrating thing, so certainly this parabolic disk concentrator will be in shape of convex mirror. Now the thing is that it converge it to a single point, because if it converges it to more than 1 to 3 points, so much of the rays will get diverted and the temperature range will not be so much high to get it utilized for different purposes. So it actually converge it to a single point itself. So correct answer is probably disk reflectors are in shape of a convex mirror, which uses the idea of concentrating solar energy at a single focal point. Okay, so the correct answer is it's not convex. Okay, so the correct answer is answer A. So parabolic disk reflectors are in shape of a convex mirror, which uses the idea of concentrating solar energy at a single focal point. These are metaphor for high surface. Okay, so when you see these, I think, yeah, here also you can see this. It's a shape. So it's a convex mirror. Convex, concentrated it to a this. This is the focal point. Okay, here also you can see the same thing. So I want you that you read this question again and try to think and visualize different type of parabolic. So I have talked about parabolic disruptor, about different other type of like compound parabolic. What is the shape? What is the focal point? How it is getting focused? Okay, so there are linear plasmar something. So these things are actually to be visualized. Most of the things, if you could visualize it, you can easily answer these type of questions. Okay. Okay, now moving to the last question. Single focal point parabolic disk reflector is said to be. Okay, so I think it's talking about the classification of different type of parabolic collectors. So it's a single focal point parabolic disk collectors. It's basically question straight from the slides itself. So it's called the imaging concentrator. Okay, why imaging? Because it is focusing the light to a particular focal point. Okay, it is actually producing an image of this solar light, so that's why it is called imaging. It's not called rough reflector because it's already mentioned it's a parodic disk reflector. Rough reflector is like this. So it's like this. This. So this is the receiver tube, and this is basically a front diagram. You can say there is a trough here. You see the side view, it's like this. This is the pipe. This is the trough collector, and it is coming to it will be focused on the single focal point flat plate parodic disk collector is said to be a imaging concentrator, so it's not of character, it's not a flat character as we have seen in this example. So the diagram also is not concentrated by this position remain is focusing the rays of the sunlight. I think most of the question have been discussed. So in today's session, we actually discussed a lot about different types of this different questions from non-graded assignments and questions from graded assignments also. Okay. So yeah, we discussed questions from non-graded assignments. We discussed questions from graded assignments. Also discussed questions regarding this. We discussed concepts. I put some pictures also to have a clear on of the different goes into this course non-conventional socialization. So we discussed black body, we discussed solar concentrator, we discussed different types of solar concentrators, we discussed about periodic test concentrator, that collectors, infrared and different types of radiation of light, wavelength of the most intense part of the spectrum, and then we discussed about black body properties, and photoelectric effect also we discussed here. This is the particle of light. So discuss what is the constituent of the particle light, how much energy it can produce, the full solar spectrum also we discussed here. That factor also. So this is the basically rheostats where I have tried to present the different type of linear arranged here with actually thousands of them surrounding this tower. So we put the receiver, it focuses the light to this tower. We the steam production which goes through the Stirling cycle produce electricity. Okay, so this is basically a system. So that is a thing that this is the last Stirling. So we can discuss questions about statement of regions also, so we know how to solve these questions. We discussed about parabolic disk reflectors and its shape. First, different types of classification of parabolic disk reflector. With this, the session of 4 can end. So I'll ask you guys to put your questions, or you can always find me at this email ID. Your question, I will ask you guys to put your question in the discussion forum so that any other students who haven't joined the session can make it. Also, this whole session is recorded, so I will upload it on YouTube. So you can go to YouTube, my YouTube channel. So let's go ahead. So, this is my YouTube channel. So yeah, note this user ID. I am uploading this live session here, week 1, week 2, week 3. You can go through the live sessions and so follow my to get the updates about the different live sessions. So you will get this course also from this. You have missed the previous live session. So okay, till then we end this live session. We will meet again next upcoming week for live session 5. Or if there are any questions, please feel free to ask it now, or you can always ask it in the discussion forum. So good night.